Students, welcome in my physics class. In this series of current electricity, we are going to start the next topic, that is resistivity or specific resistance. During the deduction of Ohm's law, in terms of electron theory, we have proved that R is equal to m upon n E square T into L upon A. M, mass of electrons; n, number of electrons per unit volume; E, charge of the electron; T, we are representing its relaxation time; L, length of the conductor; and N, A is area of cross section. Already we have studied this formula. Students, in this formula, if we pay attention, then this is again a new constant which does not depend on geometry of conductor. This constant does not depend on geometry of conductor, and I represent it by letter what? Rho. That is, R is equal to rho L upon A. What is rho? Rho is equal to m upon n square T. So what is rho? Rho is called specific resistance or resistivity of the material of conductor. Rho is resistivity or specific resistance of the material of conductor. So R is equal to rho L upon A. Let L is equal to 1 meter. We consider length of the conductor is what? 1 meter. Area of cross section of the conductor, 1 meter square. So R will be equal to what? Rho. Specific resistance of the material of a conductor is the resistance offered by a piece of that conductor of unit length and unit area of cross section. Suppose I take this conductor. Its length is 1 meter, area of cross section is 1 meter square, then the resistance across its opposite faces is called its specific resistance or resistivity. Students, remember that resistivity depends on temperature as well as material of the substance. For example, the resistivity of iron will be different that of copper. Similarly, if you will change the temperature, the resistivity will change. Now the unit. Unit of resistivity, Ra upon N. Unit of resistance is ohm. Area, meter square, length, meter. So unit of specific resistance is ohm meter. Or if length is measured in centimeter, then you can say it is ohm centimeter. Dimensions of the resistivity are m L square, m L cube, A minus 2, T power minus 3. These are the dimensions of specific resistance. Now let us study what is the effect of temperature on the resistivity of substances. In order to study the effect of temperature on resistivity, students will divide the substances into 3 categories: metal or conductor, number 2 alloys, and the third one is semiconductor. Please pay attention that resistivity is given by the formula rho is equal to m upon n E square T. It shows that resistivity depends on 2 factors. Resistivity depends on 2 factors. What are they? Number 1 L, number 2 T. That is density of electrons, and second is relaxation time. So keep in mind, resistivity of substance depends on number, density of electrons, and secondly the relaxation time. Here T is relaxation time. So let us first study for metals. In case of metals, if you pay attention, then rho is equal to m upon n t squared t. For metal, m constant, n constant, E constant. M, N, E are constant. Variable is relaxation time. So we can say rho is inversely proportional to 1 upon T. If we increase the temperature of a conductor, the collision of electron with kernel will become fast. The movement of the electrons will become fast. When the motion of the electrons will become fast, relaxation time will decrease. T will decrease. And when relaxation time will decrease, resistivity will increase. So you can say, or we conclude that for metals, resistivity increases with increasing temperature. That's why you plot a graph. Between the temperature and resistivity, the graph will be a curve of this shape. Second is your what? Alloys. The resistivity of alloys is very high. What I am saying? Resistivity of alloys is very high. So effect of temperature on the resistivity of alloys is negligible. Or we say there is no effect of temperature on the resistivity of alloys. Dear students, remember that. There is no effect of temperature on the resistivity of alloys. That's why alloys are used to make standard resistances. Question may be asked, standard resistances are made of alloy. Why? Standard resistances are made of alloy because their resistivity is very high and there is no effect or there is negligible effect of temperature on their resistivity. Next comes your semiconductor system. In case of semiconductor, there is no role of relaxation time. There is no role of relaxation time. M is constant, E is constant. Therefore, rho depends on number density of electrons. Resistivity of semiconductor depends on number density of electrons. N. Rho is inversely proportional to N. We know that at absolute zero, semiconductors behave insulators as they have no free electrons. But as the temperature of semiconductors is increased, the number density of free electrons increases. Why? Because the bonds rupture, bonds break. The covalent bond in semiconductors will rupture with increase in temperature and more free electrons will be available. So you can say N will increase. Again, rho is inversely proportional to N. So if N will increase, then a specific resistance or resistivity will decrease. So remember that in case of semiconductors, resistivity decreases with increasing temperature. So what is the conclusion? In case of metals or conductors, resistivity increases with increasing temperature. In case of alloys, there is no effect. And in case of semiconductor, resistivity decreases with increase in temperature.